Hi, so I'm going to talk you through how to answer the AQA question paper 2 for chemistry from 2024. I am going to talk through in this video the standard demand questions aimed at levels 4 and 5. So these are the same questions that are on the higher paper, which were questions 1 and 2, these were the same questions that were actually on the foundation paper as questions 8 and 9. So I will talk you through the mark scheme. I will also tell you what the examiners had to say about how students answered these questions and the percentage of how many students actually scored some marks. And later I will put together some longer videos for the whole of foundation and the whole of the higher paper as well. So you need to subscribe and then you'll be notified when they are ready. Now, what I recommend that you do is you download a copy of the paper, and I'm going to put a link below so you can do that directly. And then at the start of each question, I'll put a reference to where the content is on the specification. So I'll put a link to that as well, and you don't need to print all of it off. I'll just make sure it's the relevant pages. Because you might want to do some revision first, then attempt the question, and then listen to what I say about the answer and the examiner's comments, etc. That's probably the best way to revise, because you're actually doing something rather than just passively listening to me. So as these are the questions that are found on both higher and foundation, they are what we call standard demand and are levels 4 and 5. If you want to do some revision first, go to page 73 of the specification, have a go, and then come back and see what was on the mark scheme and what the examiners had to say. Right, so the specification says that flame tests can be used to identify some metal ions, which are known as cations, and it gives a list of the colours of the flames, and sodium is in that list. So 1 mark for saying flame test, and the result is that you'll see a yellow flame. 1 mark for each. Please note that not all metal ions can be detected in a flame test. There are other tests that you need to be familiar with as well. There is an alternative answer. If you look at page 75 of the specification, you learn about an instrumental technique called flame emission spectroscopy. So you could put that as the test, but for the result you would need to specifically say that the lines in that spectrum match sodium. Now, I would be a bit cautious with the alternative approach because flame emission spectroscopy is not suitable for all metal ions, just as with the flame test, but the specification doesn't actually tell you this. But what do the examiners say? They say that this question was generally well answered by students, with around 60% of the entry gaining both marks. The specific test and correct result were well known. The most common incorrect responses were a flame not being mentioned and the incorrect flame colour, particularly orange or crimson. The alternative method of gaining the marks using flame emission spectroscopy was very seldom seen. Okay, next for revision, you need to look at page 74 and halides in the specification. So this question's not about the test for chlorine. It says chloride ions. The test for chlorine is on page 73 of the specification, but that's for the gas Cl2, not Cl-, which is what is being referred to here. But I can see as students, while you're still learning, how that mistake could be made, because they do not specifically say in the specification chloride, bromide, iodide, for example. They just call them all halides. So the specification says halide ions in solution produce precipitates, which are insoluble salts or solids, with silver nitrate solution in the presence of dilute nitric acid. Now that is correct, but they're quite generous on the mark scheme because they've put brackets around add acidified, so that part is not essential. There's also brackets around the word solution because the silver nitrate does have to be dissolved in water, but they're not saying that the word solution is essential. There's only one possibility for the test result, and that is that a white precipitate is formed. Now it's worth pointing out here that you can only get the mark for white precipitate if you have correctly said that the test is using silver nitrate. Now I can see why the examiners have done that, because there are a lot of different qualitative tests that produce a white precipitate. Right, so what did the examiner say? This may amuse you actually, because the first thing that they say is that the test for chlorine was not well known. But I'm sorry AQA, the test is for chloride, and you've pointed that out as a mistake that students make. They then go on to say, just over 1/3 of students gained both marks. If an acid was mentioned, it was almost always nitric acid. Some other tests were chosen, with the most common incorrect responses being the addition of barium chloride or sodium hydroxide. A number of students mentioned the test for chlorine gas rather than chloride ions and described the use of damp litmus paper. The mark for the result of the test was dependent upon a mark being awarded for a correct answer. Okay, let's move on. Right, now it looks like this question is referring to required practical 8, which you should have carried out, which is the analysis and purification of water samples from different sources, including pH, dissolved solids and distillation. If you have done it, not the most exciting practical, but more on that in a moment. Right, so let's just have a quick talk about this practical in case you haven't done it. Your school may have been limited for time, but really you are supposed to have done all the required practicals, and that should be signed off and presented to the exam board. Right, now, so what are they doing here? They're finding the concentration of sodium chloride in salt solution rather than water samples. So it's transferable knowledge really. So they're taking an empty evaporating dish, putting a known volume of salt solution into it, heating it, weighing afterwards, then repeating until there's no further change in mass, and then repeating 3 more times the whole thing with different samples. Right, so the question is, why did the student heat the evaporating dish and contents until the mass did not change? Right, so the only answer on the mark scheme is to ensure that all the water has evaporated. Right, so what do the examiners say? They say only around a quarter of students were awarded this mark. The use of words such as solution or liquid were common, uncreditworthy responses. The removal of all the water was also not indicated by many students. Well, this got me thinking, how can this be that so many students did not get these marks? So I did a little bit of investigating and I looked up the required practical in the official AQA handbook. So this has got the instructions in for the teacher, the technicians that get the practical ready, and the worksheets for the students to use. So listen carefully to these instructions and let's see if you agree with me about where this error has come from. Okay, so the instructions are: heat the evaporating basin on a tripod and gauze using a Bunsen burner until the solids start to form and the majority of water has evaporated. Weigh the cooled evaporating basin again and calculate the mass of the solids that were dissolved in the water. Well, in my mind, I'm picturing that experiment and I'm thinking, what's in the cooled evaporating basin? Yes, there may be some solids that have started to form, but there's still some water in there because it says the majority of water has evaporated. So in my mind, this is possibly where this error has come from in student answers, because it's the instructions that they have followed in the required practical that has been set by AQA and their teachers have followed. But it's not logical, because how can that tell you the mass of the dissolved solids if there's still water there? So the exam mark scheme is correct. But moving forwards, AQA should be teaching this correctly, using the correct terminology as well, because this is known as weighing to constant mass. Hopefully your teacher spotted the error and you were taught correctly. Right, so how did the student actually calculate the mass of the dissolved sodium chloride at the end of that experiment? Right, so very easy. Mass of the evaporating dish and the dry contents, in other words all the water's evaporated, minus the mass of the empty evaporating dish. So you're just measuring the dry contents, the dry sodium chloride. Not much more to say on that, except that the examiner stated this multiple choice question was very well answered, with around 85% of students gaining credit. Okay, so we've got a 4-mark calculation question here. So because it's 4 marks, that means it's a multi-stage calculation, but often with these things you can get the first mark or 2 just for something quite simple. So the information in the question refers to the percentage by mass of sodium ions in sodium chloride, and it gives a percentage. So that is actually referred to in the specification on page 37 under the section relative formula mass, if you need to revise that. Just want to point out that when it says percentage by mass of sodium ions, you do that in exactly the same way as if it said sodium atoms, because a sodium atom becomes an ion by losing just 1 electron, and that electron has negligible mass, so you can treat it as 0. But you are given the final answer, and we're going to be using that along with the mean concentration of sodium chloride to find the answer. Now, as I said earlier, there's always something quite easy to do at the start of these questions, whether it's about unit conversions, especially in physics, finding averages. So everyone should be able to at least have a go at this question. Hopefully you've attempted all of it. But I think I know students pretty well, and they're probably looking at these 4 trial results, wanting to calculate the mean or the average, and thinking, well, do I use all of them? So you're probably looking at those results and thinking, well, they're not that close together, are they? You may have learned about concordant results in titration, so that's probably going through your mind as well. Do I discount some of these results? Well, there's nothing there to tell you to do that. So use all 4 results to come up with the mean. If you only use 3 of the results, if you discount trial 3, then you are actually going to lose a mark. So in this case, there's nothing to suggest discounting a result. So use all 4 and come up with an answer to 1 decimal place, the same as the data you've been given, but keep the whole answer in your calculator for later. Now, I can almost guarantee that you're going to have to calculate a mean or average in biology, chemistry and physics. So we're finding an average of 4 results, so we add all 4 together and divide by 4. Now, there isn't anything in the mark scheme to say that if you get the final answer correct, that you'll get all 4 marks. In fact, just for this first part where we're calculating the mean concentration of sodium chloride, which is worth 2 marks, there's 1 mark for the answer, but there's specifically a mark for showing you working. Right, so I've written my answer slightly differently to the mark scheme, just to try and explain logically how to do this. So we've already found that the mean concentration of the whole thing, the sodium chloride, is 35.0 grams per decimetre cubed. So if we divide by 100, that tells us what 1% is worth. And then if we times by 39.3, that tells us how much of it is just the sodium ions. Right, so what did the examiner say? They said this calculation was generally answered well by most students. Around 2/3 gained all 4 marks. Those who did not complete the calculation usually gained 2 marks for correctly determining the mean concentration of sodium chloride. Right, so if you want to do some revision first for question 2, the Harbour process is on page 88 of the specification, tells you what you need to know. So you can see in the diagram, something is going back around from the condenser. You know what the reactants are, you can see those going in at the top, and you were told this in the specification. So it's to allow the hydrogen and nitrogen that haven't reacted to go back into the reactor, or you could say to recycle unreacted gases. Okay, so what did the examiner say? Well, you need to make sure that you're referring to both of the gases, so you either say both of them or hydrogen and nitrogen, but it's the idea that they are being recycled or passed through again because they are unreacted. So only about 40% of students got a mark on this question. So other things that they might have said that were incorrect was about referring to excess gases or just the word gases. Some students, it says, focused their answer on the condenser part and responded with the idea that uncondensed gases needed to be recycled. Well, that's wrong as well, because that could refer to the ammonia. Remember, that is condensed so that it cools and liquefies, so it runs out, it's being collected. Right, so this one's just an easy, straightforward recall question, not much to say on this. So 2/3 of students remembered correctly that it's iron, or you could put the symbol Fe. Right, another easy question here on the test for oxygen gas. So from previous years, I would say that of the gas tests, hydrogen, oxygen, carbon dioxide and chlorine, you usually ask 2 of those across the 2 papers. If you do need to revise, then look at page 73 on the specification. So a simple test, you need a glowing splint, and the result is that it relights. If it helps you to remember, think of it as completing the fire triangle. So you've got the oxygen, you just need the other 2 parts. So you've got the heat, because the splint is glowing, the splint is the fuel, you've got all the 3 components needed for fire. That's why it relights. So what did the examiners say? Well, although this question was answered well, some students referred to a splint being lit initially and then blown out. These students did not often mention the splint was still glowing. Remember, I've just said you need the heat, if that helps you to remember. The majority of students who stated glowing splint also gained the 2nd marking point. Around 3/4 of students gained both marks. Of those who did not, most described the test for hydrogen. Well, that's the squeaky pop test, isn't it, with the lit splint. Right, for reaction profiles, have a look at page 53 of the specification to see what you need to know. So this is what your answer should look like. So for the activation energy that you were told to add, it should be a labelled vertical arrow from the dotted line up to the peak. So it should only point upwards strictly, but they are a little bit generous and said ignore arrowheads. In fact, if you look at BBC Bite Size, they get this wrong. Have a look later. They do a 2-headed arrow pointing up, pointing down. That is wrong. You have to put energy in, so it's pointing upwards. You also needed to put on the reactants and the products. So you can do that in words, or you can put the formulae, but the formulae have to be correct. So we're after capital N, capital H, little 3 for ammonia, capital O, little 2 after it for oxygen, HNO3 for nitric acid, all capitals, H2O for water, all capitals. Now what else do they say? You could label the activation energy, instead of using words, you could put EA, so that's a capital E with a little a after it. That's correct. And what else? Oh yeah, it says more than 60% of students gained both marks, so not bad, this one. But as you can see, the people who should know better still make mistakes as well. So for allocation of the marks, it's 1 for the activation energy labelled, and the second mark is for putting the reactants and the products, both of those, in the right place. Now, just before we move on from this, in case you get one of these in your real exam, if the question gives a balanced symbol equation and you have to put this onto your diagram, then make sure that you include the balancing for the reactants and the products on those lines in the diagram as well. Right, now to find the answer to this, you need to look at page 58 of the specification in the section about catalysts. It's not actually in the bit about reaction profile diagrams. Right, so without a catalyst, the peak would be higher. Remember what a catalyst does? It provides an alternative reaction pathway with a lower activation energy. So if there isn't one there, it's going to be higher. So the examiners say this was well answered, with around 70% of students getting the mark, but the most popular distractor was that the peak would be lower rather than higher. So if you want to revise this first, go to page 89 of the specification, which is about production and uses of NPK fertilisers. So based on the specification, the answer is as fertilisers. Now, not on the specification, but allowed as alternative answers, you could also have correctly said as explosives and in sports packs. So the examiners also say this question was answered extremely well with fertiliser or NPK fertiliser. A small minority stated farming or agricultural use, but this was unqualified. So in other words, they didn't say exactly what for on a farm, so that they couldn't score the credit. But only a handful of students said the alternative answers that I've just given, as in explosives and in sports injuries packs. So I think this question is a really good example of why you have to read all of the question carefully, maybe underlining or highlighting as you go. So the information is actually describing 2 reactions. Now the question relates to the first reaction, although the 2 reactions are related, and you also have to make sure that you tick 2 boxes. So the answers are combustion and reversible. So the specification references that you want are on page 59 and 79. So quite a bit to say on this really, because the examiner's report says this multiple choice question proved challenging, with around a quarter of students gaining 2 marks. However, the vast majority were able to score 1 mark. Now, what do I think? Well, I'm not surprised that students would be confused under exam conditions the way this question's written. But it does mean that you need to read and think about the question carefully and then eliminate answers that are obviously nonsense, such as alloying and corrosion, because we're not looking at anything to do with metals. Now, something about using electricity may make you think of putting in energy, and so endothermic. But the combustion answer refers to the reaction between hydrogen and oxygen gas, which is in the line asking which 2 words, which is just like when you do the squeaky pot test for hydrogen. You may also have thought about the reaction in a hydrogen fuel cell, which may have influenced you away from the combustion answer. So there'll also be students, I think, that do not notice that two answers are needed, even though it's shown in bold twice. Right, keyword here is equilibrium, so have a look at page 59 of the specification if you want to revise first. So bottom of page 59 says equilibrium is reached when the forward and reverse reactions occur at exactly the same rate, so it has to be the second option there, and the examiners say that more than 90% of students gained credit. So all questions in this video have been targeting levels 4 to 5, and they appeared on both the higher and foundation papers. I will put together 2 more videos for the rest of foundation and higher level, so if you click on subscribe you'll be notified when they appear. I've also put together a GCSE Chemistry escape room that assesses the knowledge that's in the specifications for higher and foundation, separate sciences for chemistry, in other words, triple award, but also combined award for trilogy and synergy as well. So everyone should be able to answer those, ready for the real GCSE exam. So a bit of fun there.